Hi friends, welcome you all to Think Max. We are in class 10 Max, chapter 10 Circles. In this session, we are going to discuss about exercise 10.2, question number 5. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. So, here for a circle, so this is the circle, we are going to draw the tangent. So, this is the tangent. AB is the tangent, it meets the circle at P. So, P is the point of contact. So, let us take O. This is the center of the circle. So, OP will be the radius of the circle. So, for a contradiction, we are going to take a point X such that XP is perpendicular to AB. So, let us see what will happen to this contradiction. So, first let us write what is given. It is given that AB is the tangent intersecting the circle at P. O is the center of the circle. So these 2 points are given. What we have to prove? We have to prove if we draw a perpendicular on AB at P, this perpendicular should pass through the center. So to prove this, we are going to take the contradiction. So what is the contradiction? Let X be a point such that XP is perpendicular to AB. So what will happen? This means angle XPB equal to 90 degree. Okay. Now here OP is the radius and AB is the tangent. What we know about radius and tangent? We know OP is perpendicular to AB. What is the reason? From theorem 10.1 we know radius and tangent are perpendicular at point of contact. So P is the point of contact. So OP will be perpendicular to AB. This is by theorem 10.1. Now we got OP perpendicular to AB. So this angle OPB will also be 90 degree. That is angle OPB will also be 90 degree. So let us assume this as 1 and this is 2. So what we get from 1 and 2? From 1 and 2 both are 90 degree. That is angle OPB is equal to angle XPB because both makes 90 degree. So we all know if we draw a horizontal line and if we draw a line with angle 90 degree, it will be vertical. Okay. So if there is a line in this way, this will not make 90 degree. So this will not be 90 degree. So only the vertical line will make 90 degree. So we got angle OPB is equal to angle XPB. Is it right? No, this is possible. Only this XP coincides with OP. Okay. So angle 90 degree will be vertical to this AB. Okay. So therefore we can write this is possible only when XP coincides with OP. So who is O here? O is the center of circle. So X coincides with O. That means the perpendicular to AB should pass through the center. So we can write perpendicular to the tangent passes through center. So with this, we conclude this proof of question number 5. So here, if we took a point X, another point X such that XP is perpendicular to AB. So we will get angle XPB is equal to 90 degree. Another one is OP is radius and AP is tangent. So OP will be perpendicular to AB by theorem 10.1. So angle OPB will also be 90 degree. So both are 90 degree. So this is not possible. So if you check this line, this makes a slant line. So slant line doesn't make 90 degree. So if both are 90-degree, then X should coincide with this O. Okay. So if X is coinciding with O, that means if you draw a perpendicular to tangent AB at the point of contact P, so this perpendicular will pass through the center. It doesn't make any other point. It will always pass through the center. So this is the proof. I hope you are clear with this proof. Thank you. Thank you for watching. Bye.